In this video, I am going to explain about concepts of haloalkanes and haloarenes. That means organic compounds containing halogens. So first we'll discuss synopsis points. See here. The groups possessing two nucleophilic centers are known as ambident nucleophiles. Two nucleophilic centers are known as ambident nucleophiles. That means Cn minus SCN minus NO2 like that. Next, rate of reaction depends on concentration of both alkyl halide and base is known as SN2 reaction. So in case of SN2, rate is dependent on rate equal to rate constant into concentration of alkyl halide as well as nucleophile. So here order 1 plus 1, 2. This is SN2 mechanism. Next, in case of SN1, rate depends only on concentration of alkyl halide. Therefore, order equal to 1. This is SN1 mechanism. Remember these 2 points. Next, see, rate of reaction depends on concentration of alkyl halide only means SN1 reaction. Next, order of reactivity of alkyl halides for SN1. So, tertiary, secondary, primary and methyl. So, order of reactivity for SN2, tertiary, secondary, primary and methyl. So, in case of SN1, tertiary highest. In case of SN2, methyl is highest. Next, in case of SN1 or SN2 mechanism, reactivity order of alkyl halides Ri, RBr, RCl, Rf. Ri highest reactivity due to large size of iodine. Next, if all the substituents attached to carbon atom are different, that carbon is asymmetric carbon or stereo center or chiral center. Chiral center. Very, very important. Next, the stereoisomers related to each other, non-superimposable mirror images are enantiomers. And non-superimposable non-mirror images are diastereomers. Remember these two. Non-superimposable mirror images are enantiomers. Non-superimposable non-mirror images are diastereomers. Next. Say a mixture containing two enantiomers in equal proportions will have zero optical rotation, as the rotation due to one isomer will be exactly cancelled by a rotation of other isomer. Such mixture is known as racemic mixture or racemic modification. So very, very important. Next. So the process of conversion of enantiomer into racemic mixture is known as racemization. Racemization. Next, in SN2, reactions of optically active halides accompanied with inversion of complete inversion of configuration takes place. That is, in case of SN2 mechanism, complete inversion of configuration takes place. In case of SN1, it is accompanied by racemization. That means, so both plus isomer minus isomer will be formed in equal proportions. Next. So reaction of benzene diazonium salt with cuprous chloride or bromide with HCl gives chlorobenzene or bromobenzene is known as Sand-Meyer's reaction. Very, very important. Next. So chlorobenzene reacts with chlorine in the presence of AlCl3 gives 1,4-dichloro as major product, 1,2-dichloro as minor product. This is best example for aromatic electrophilic substitution. Chlorobenzene reacts with nitration mixer. It gives 1-chloro-4-nitrobenzene as major product and 1-chloro-2-nitrobenzene as minor product. This is the nitration of chlorobenzene. This is also aromatic electrophilic substitution. Next, chlorobenzene reacts with CH3Cl alkyl chloride. In the presence of AlCl3 gives 1-chloro-4-methylbenzene as major product and 1-chloro-2-methylbenzene as minor product. This is Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation. Next. Chlorobenzene reacts with CH3COCl acetyl chloride. In the presence of AlCl3 gives 4-chloroacetophenone as major product and 2-chloroacetophenone as minor product. So this is Friedel-Crafts acylation reaction. Next, reaction of chlorobenzene and alkyl halide with sodium in the presence of dry ether gives alkyl benzenes. This is Wurtz-Fittig reaction. Next, reaction of chlorobenzene with sodium in the presence of dry ether gives diphenyl. This is Fittig reaction. Next, para-para-dichloro diphenyl trichloro ethane is known as DDT. So let's structure of DDT. Very, very important. 3 Cls. And here Cl. So 2 times it was asked in mains. Here 1 and here 2. So this is structure of DDT. So in DDT structure, we have 5 chlorine atoms. This is previous 5 chlorine atoms. Very, very important. So powerful insecticide. DDT, dichloro, diphenyl, trichloro, ethane. So next we will discuss worksheet questions. So first worksheet question. The major product in the following reaction is, so here given compound is a double bond CH2 is given. So first it reacts with HBr and the given compound is here peroxide. So anti-Markovnikov's addition of HBr. So in the presence of peroxide, anti-Markovnikov's addition. So therefore it gives CH2 and here Br. CH2Br. So next reaction with KCN, alcoholic KCN, it gives corresponding cyanide. So this is SN2 mechanism, displacement of Br minus by Cn minus. Next, after that, hydrolysis. H3O plus and delta. So Cn group will be converted to COOH. COOH, that means CH2 COOH. So this is major compound. Check here once. So check options. Option C. C6 H11 CH2 COOH. This is the major compound. Major. So first anti-Markovnikov's addition, next nucleophilic substitution, next hydrolysis. Option C. Next. The major product of the following reactions. So first reaction, benzene plus Br2 FeBr3. Br2 FeBr3. Aromatic electrophilic substitution will get first Br. So bromobenzene. Next, it on reaction with CH3Cl and AlCl. So here bromine is electron donating group, that means ortho and para directing group. It will give major compound. Para substitution CH3. Next, which on reaction with magnesium dry ether gives MgBr and CH3. So next, it on reaction with CH3CHO, which is acetaldehyde. Acetaldehyde. So here dissociate like this. Here plus and this total minus. Here delta minus and delta plus. Therefore, it gives intermediate compound like this. Here CH3. Here C. CH3. H and O MgBr. So which on hydrolysis will give final compound CH3, CCH3, here H and OH. Check the options. Option B. So very important reactions. Option B. Next. The chiral compounds among the following are. Chiral means carbon atom must be attached to four different atoms or groups. Check here options. Very important. Here I is present. Iodine and CH3. Iodine above the plane like this. And CH3. Here CH3 and CO. So this carbon is chiral center or chiral carbon. So this is fourth compound. Next, check sixth compound. CH3 above the plane, H below the plane. Next, C2H5. C2H5, ethyl and Cl. So this is also chiral carbon. So this is sixth compound. Therefore, 4 and 6 compounds are chiral centers. Carbon atom is attached to 4 different groups. So a nucleophilic substitution, decreasing order of nucleophilicity. Nucleophilicity means attack of nucleophile on electron deficient carbon. See here it is given CH3, CH2Br displaces nucleophile like this. Here delta minus and delta plus. So this nucleophile attacks this CH2. Br minus will be leaving like this. It gives CH3, CH2, Nu plus Br minus. This Br minus is leaving group. Since it is leaving from molecule given substrate, it will be known as leaving group. So which nucleophile attacks easily? So here one small CH3 should be there here, CH3. Here also CH3, CH4. CH3, here also CH3. So nucleophilicity order will be given by first CH3, O minus best nucleophile. So due to more amount of charge on oxygen. So methyl group is electron donating group. Methyl is electron donating. After that, the OH minus. After that, phenoxide ion. Phenoxide. It is somewhat stable due to conjugation. Last CH3COO minus acetate more stable. When compared to phenoxide ion, acetate ion is somewhat more stable. So CH3O minus methoxide ion is more nucleophilic when compared to OH minus, which is more when compared to phenoxide, which is more when compared to acetate ion. So this is order. 4, 3, 1, 2. Option A. CH3O minus methoxide ion can attack electron deficient carbon easily. So due to high stability, acetate ion cannot attack electron deficient carbon. Remember that point. Nucleophilicity order. Next. So major product in the following sequence. First it is given ketone which are reaction with ET MgBr. ET means ethyl. Here minus and plus. Therefore, so here delta minus and carbon delta plus. Therefore, attacking at carbon, it gives ET OMgBr. So ET means CH2 CH3 we can write. CH2 CH3 ET. So which on hydrolysis will give here H and OH. Here OH. So minus MgBrOH. This will be eliminated. Next. After that, H3PO4, which is dehydration minus H2O. It will form alkene. Like this, alkene. Major compound is alkene. Next, which on reaction with HBr. Markovnikov's addition of HBr. So final compound will be like this. Here Br will come. So check the compound. Option C. This is major. So first nucleophilic addition followed by hydrolysis. Next dehydration. Next electrophilic addition. Markovnikov's addition of HBr. Next. So which are the following alcohols will give turbidity almost immediately with low cost reagent. So low cost reagent is anhydrous ZnCl2 plus concentrated HCl. This is a low cost reagent. So tertiary alcohol gives turbidity immediately. Next, secondary alcohol gives turbidity after 5 minutes. Primary alcohol, no turbidity. So that means tertiary alcohol is most reactive. We can select tertiary alcohol. So tertiary butyl alcohol, that is 2. Next, benzyl alcohol, that is also most active. Next, allylic alcohol, that is also more reactive. Tertiary alcohol gives turbidity immediately means most reactive. So most reactive alcohol will give turbidity immediately. So therefore 2, 3, 4 most reactive alcohols. Therefore these 3 compounds can give option C. So first one is primary alcohol, that will not give turbidity. So very important. Most reactive will give turbidity immediately. Next, see here. So option A. First CH3, CHBr, CH2Br, which is an alcoholic KOH. So remove minus HBr. Minus HBr will be removed. Therefore it forms CH3, CH double bond, CHBr. Alkenyl bromide. Alkenyl bromide, which is 4. Next, option B. CH3, CH2, CH2. 1 butene with HBr peroxide. HBr peroxide, which is anti-Markovnikov's addition, that gives anti-Markovnikov's addition. CH3, CH2, CH2, CH2Br. So primary alkyl bromide, so which is 1. Next, C. CH3, CH2, CH3. Halogenation, that means bromination in the presence of sunlight. So this carbon will be most active. That gives secondary alkyl bromide. Which is 2. Next, last D, propene. Propene with NBS. So NBS is selective reagent for allylic benzylic bromination. That means it gives CH2Br, CH2. Allyl bromide. So which is option 3. So here 4, 1, 2, 3. 4, 1, 2, 3. Option D. Next one. The reactivity of alkyl bromides in dry acetone. In dry acetone. Very important. So in dry acetone, so which is almost non-polar solvent, mechanism is SN2 mechanism. So as bulkiness decreases, SN2 mechanism increases. Therefore, SN2 order. First, simple alkyl halide. Simple alkyl halide is 4. So after that, 1 primary. So this is ethyl. Fourth one is methyl bromide. So first one is primary. Next, after that 2. 2 is secondary bromide. After that 3, which is tertiary. So methyl bromide is most active towards SN2 mechanism. Therefore, option A. 4, 1, 2, 3. Next. So which among the following is most active towards SN2 mechanism? So primary alkyl bromide will give SN2 mechanism. So out of 4 options, which is primary? Option B. So option B is primary. That is CH3, CH, CH3, CH2, CH2Br, which is primary. Therefore, it is most active. CH2Br means primary alkyl bromide. Primary alkyl bromide. Most active. Next. The reaction of 1-bromohexane with aqueous NaOH follows the order. So 1-bromohexane. Here 1-bromo, CH2, CH2, total 6 carbons. So 1-bromohexane, which is primary alkyl halide. So with aqueous NaOH, so undergoes a mechanism SN2 mechanism, SN2. It gives CH3, CH2 totally 1, 2, 3, 4, 5 times OH corresponding alcohol. That means 1 hexanol. So according to kinetics, rate of reaction depends on concentration of alkyl halide, which is Rx. So this can be treated as Rx. And NaOH will be, say, nucleophile. Nucleophile. Concentration of alkyl halide as well as concentration of nucleophile. So here power 1, 1. Therefore, order equal to sum of powers 2. So therefore, second order kinetics. In SN2, rate of reaction depends on concentration of alkyl halide as well as concentration of nucleophile. Next. So here bromopentane reacts with AgCN to give isocyanide. Isocyanide, which is correct. AgCN gives isocyanide with alkyl halide. So because AgCN is covalent. The bond between Ag and C is almost covalent. Therefore, A is true, but AgCN is mainly ionic. That is wrong. A true or false? Option C. Next. So which among the following will have highest density? So density equal to weight by volume. So therefore, higher the molecular weight, higher will be the density. Very, very important. So molecular weight is more for option B. So option B, N-propyl iodide has high molecular weight, therefore high density. Very, very important. Option B. The mass per unit volume increases. Here van der Waals forces also present. Van der Waals force. So due to van der Waals force, volume decreases, and due to high molecular weight, weight increases. Weight increases, volume decreases. Therefore, density will be very high. Next. So when 1-chlorobutane is treated with aqueous KOH, it gives P. 1-chlorobutane. Treated with aqueous KOH. So aqueous means here polar solvent. Polar protic solvent. Polar protic solvent means, so here elimination favors. Elimination dominates over substitution. Therefore, it gives, so minus HCl, dehydrohalogenation. So which is P alkene, 1-butene. So P is alkene. Next. So same compound with alcoholic KOH. So alcoholic means non-polar almost. So it favors substitution. Therefore it gives CH2, CH2, CH2OH. So 1-butanol, which is Q. So P is alkene, Q is alcohol, option C. So alcohol means almost non-polar solvent. Non-polar medium. Non-polar solvent favors substitution. Polar solvent favors elimination. Next. Identify the product of the following reaction. Here CH, double bond, CH3, HBr. Next, so this carbon is benzylic carbon. This carbon, benzylic carbon. So positive charge at benzylic carbon is highly stable. Therefore, first it gives CH double CH, and here CH, CH3, make it plus and minus. Next add HBr. Therefore it forms CHBr, CH2, CH3. Now check the option. Option B. So bromine at benzylic carbon. Bromine at benzylic carbon. More stable or major compound. Next. So what is the product of reaction given below? The SN1 reaction is given. You can take here OH minus nucleophile. OH minus. So given alkyl halide is tertiary, therefore it undergoes SN1 mechanism. SN1. First it gives carbocation, tertiary carbocation. So which will be attacked by OH minus from two sides, front side and back side. It will give CH3, CH3OH. Here OH minus nucleophile attack. SN1 mechanism, tertiary carbocation. So OH minus attacks carbocation from front side and back side. Therefore option D. OH minus is nucleophile. Next. So which among the following is most common in alkyl halides? So alkyl halides undergo nucleophilic substitution. Nucleophilic substitution reactions. So simply A. We can write like this. Suppose CH3Br plus take OH minus. OH minus is nucleophile. So delta minus and delta plus. So OH minus attacks electron deficient carbon to form CH3OH plus Br minus. Here Br minus is leaving group. So generally alkyl halides undergo nucleophilic substitution. Next. So what are X and Y in the following sequence? So here first it is given CH3 and below the plane hydrogen, above the plane ethyl group, C2H5 ethyl group, here Br. Next KCN. KCN means here SN2 mechanism. Take SN2 mechanism. It gives here, one second, hydrogen, CH3 and ethyl group. Here CN, cyanide will be formed. Next, after that, hydrolysis. H3O plus. So Cn will be converted to COOH, means carbon, CH3, H, C2H5, and here COOH. So the compound is X and this is Y. First cyanide, next carboxylic acid. Take here option B. Option B. Next. Select the following organic halides in correct order of their reactivity towards SN2 displacement. So SN2 means first primary, secondary, tertiary should be there. SN2 order. So first here CH2Br is given Q. So Q is primary. After that, next R is secondary and P is tertiary. This is SN2 order. Primary alkyl halides SN2. Tertiary alkyl halides SN1. So option Q or P, D. Next. Identify the statement which is not correct. So dehydrobromination of 2-bromopentane gives 1-pentene as major compound. So that is only wrong. Simply 2-bromopentane. 2-bromo. Here CH2, CH2, CH3. Dehydrobromination, that means alcoholic KOH. It gives. So two compounds here, alpha, beta and beta. Two beta carbons are available. Two compounds are possible here. First compound CH3, CH double bond, CH, CH2, CH3. 2-pentene. So which is HF compound major. Next, one more product. CH2 double bond CH, CH2, CH2 and CH3, 1-pentene. So which is minor. So one is incorrect. Stage of elimination. Stage of elimination. So major compound is Sage-F product, minor compound is Hoffman product. Next. So this reaction between aryl halide plus 2 moles of sodium plus Cl CH3 in dry ether. So this one aryl halide and this one alkyl halide. So 1 mole of alkyl halide, 1 mole of aryl halide will give NaCl will be removed. Alkyl benzene, that means methyl benzene. So this is Wurtz-Fittig reaction. Wurtz-Fittig reaction plus 2 moles of NaCl. So alkyl benzenes will be formed. Wurtz-Fittig reaction, option A, named reaction. Next. So here first ethyl alcohol. Ethyl alcohol can be written as like this. CH3 CH2OH, ethyl alcohol. So very important. With I2 Na2CO3. So which is iodoform reaction. Iodoform reaction. So this carbon will be converted to iodoform. That means CHI3 iodoform, which is yellow PPT. Plus remaining compounds will be HCOONA plus NaI plus CO2 plus H2. So main compound is iodoform, yellow PPT or triiodomethane. Triiodomethane. Very important. So option B. So balancing here 5. Here 3 moles of Na2CO3 and 4 moles of I2. 1 mole of iodoform. Next 3 moles of CO2 and 2 moles of H2. Best example for iodoform, haloform reaction. Next. Identify the products A and B. So Rx plus AgCN, first it gives isocyanide A plus AgX. Similarly, Rx plus KCN gives R C triple bond N cyanide, which is B, plus KX. So this bond is here covalent and this bond is here ionic. So cyanide measure, isocyanide measure. Here B is measure, here A is measure. Option A. First isocyanide, next cyanide. Next. So in which are the following pairs of halogen compounds? Which compound undergoes faster in SN1 reaction? So SN1 reaction order: tertiary, secondary, primary. This is the order. Tertiary alkyl halides are most active. So in first case, tertiary alkyl halide is this one. In first example, tertiary alkyl halide. Next, in second case, so primary and secondary both are present. Between primary and secondary is more active. Therefore, secondary alkyl halide. So therefore, in first option, first compound, second option also first compound. Therefore, option D. Next. The correct order of reactivity of compounds towards SN2. So we know SN2 order. Primary highest, tertiary least. So out of given compounds, check here CH3 should be there. CH3, C6H5 like this. Here CH3, C6H5. Here also same. H and CH3 here should be. Here H, here hydrogen and methyl. Next. Check here first. Primary. Check primary. Here first one. This is primary alkyl halide. Next one. Here it should be like this. H and CH3. Here H and here CH3. So first one primary. Next secondary with methyl group. Next also secondary with phenyl group. Next tertiary. So as the bulkiness increases, SN2 decreases. So therefore, here first option A. A is correct. Check once. First primary, next secondary, two types are there. Secondary with methyl group, less bulky group. Next secondary with phenyl group, bulky group. Next tertiary. So A option is correct. So very important example. So IUPAC name of this compound. Here NO2. So all our substitutions here we must follow least sum rule. So we must follow least sum rule. Here 1, 2, 3, 4. So name will be, so in alphabetical order, first 4 ethyl, 1 fluoro, next 2 nitro, benzene. So substituents must be in alphabetical order, E, F and N. Therefore option A, least sum rule must be followed. Next. So in the reaction, here it is given CH3, CH, CH3, CH2, MgBr. That reacts with CH3, NH2 can be written as here minus and plus, active hydrogen compound. So here also this is plus and this one minus. Opposite charges will be attached. So here it gives CH3, CH, CH3 and CH3. So this is isobutane. A number of possible isomers for organic compound X. This is X. So for isobutane, can write isobutane and N-butane. So these two are isomers. That means simply chain isomers. So option C, 2 isomers. Butane can exhibit 2 chain isomers. Next. The compound having longest CCl bond. So longest CCl bond. In first example, here it is conjugation between Cl and a double bond. So due to conjugation, bond length decreases. So B, no conjugation. So double bond is far away from chlorine, no conjugation. No conjugation. Next C. Conjugation. If chlorine is attached to benzene, it will be conjugated compound. Conjugation. Next option D. It is also conjugated compound, vinyl chloride. So due to conjugation, so there will be delocalization of lone pair and pi bond. So due to this, CCl bond length decreases. Therefore, in option B, since there is no conjugation, it will be having more CCl bond length. Cl bond length. Okay, option B. Next. So tertiary alkyl halide is practically inert to substitution SN2 due to the presence of steric hindrance. So SN2 order is and SN1 order is so due to steric hindrance, tertiary alkyl halides are resistant to SN2 substitution. So tertiary will undergo SN1 mechanism. Yes, so theory person only. Next. So reactivity order of alkyl halides. So Ri, Rbr, RCl and Rf. So here more bond length. More bond length means iodine is better leaving group. So leaving group tendency, iodine, bromine, Cl and F. So better leaving group is iodine. Better leaving group. F is poor leaving group. Important. Option B. Next. So hydrolysis of optically active 2-bromobutane with aqueous NaOH results in the formation of 2-bromobutane. 2-bromobutane. So if it undergoes SN1, secondary alkyl halide, so first it gives CH, CH2, CH3 plus carbocation. So carbocation will be attacked by OH minus from two directions, above the plane and below the plane. So it gives OH which is optically active. Therefore it gives racemic mixture butanol 2. Racemic mixture. So due to formation of carbocation, OH minus can attack that carbocation from either side, that is above the plane, below the plane. Therefore it can form two isomers, plus and minus. Racemic mixture will be formed. Option B. So this is the end of the chapter. Next video I will explain one more chapter. All the best and thank you.